Jai Hind everyone. I'm Dr. Sanjay Sharma, faculty in Department of Applied Science and Humanities, Ajay Kumar Garg Engineering College. Today in this lecture, I'm going to discuss the very important topic from module number 4, which is multivariable calculus number 1. And the name of the topic is change of order of integration. In this topic, basically, we understand what are the basic concept behind to change the order of integration, and in this lecture we also must understand then what happen when we change the order of integration. Even we must understand then in some case the integration, the given format, proper format of integration may be some tough integration, but when we change the order of the integration and we next evaluate the integral, it becomes so much easy. So moving forward with this, and now understand what is the meaning to change the order of integration. When basically we are talking about, when we are talking about the double integration, basically it take place in case of double integration, right? Let's take this integration where a is the like any reason where this double variable integration being evaluated, right? So what happened basically when we are talking about the limit form of the integration, student, there must be one constant limit always, and the other limit must be variable, right? It may be in y or it may be in x. I have mentioned both the type of the integration. So first of all, we must understand in case of double integral, there must be one thing which is fixed, that one limit must be constant, and the second, it may be in y or it may be in x, must be variable, so that we can properly evaluate where the integration basically working. So it can be targeted by taking the x value constant and by taking the functional y variable, right? It also may be converted by taking y as constant here and x as variable. So this is the main formulation of a double integration, right? So now basically we are going to change the order of integral, and the meaning to changing the order of integration is that here student, you can see this is a constant limit and the second limit is being in like x. So it is mentioned in x, that means this is y limit. Here y is a variable, right? The limit is x1 and x2 mentioned, then the limit is must be of y. Here if y1 to y2 is the limit mentioned here, then the limit must be of x, right? So here x is variable and where y is a constant. Here student, y is a variable, then obviously x become the constant one, right? So when we basically change the order of the integration, what we have to plan? Basically, we convert the pattern of the integral where the integral is constant in y, we must convert the integral like variable in y and constant in x. Same here. If the limit of the question is constant in x, then by changing its order of integration, we must convert the question variable in x, and obviously it become constant in y. So this is the main agenda behind to change the order of integration. Now student, let's clear it by taking some examples, so you better understand by taking some examples here. So there is one example. I need to evaluate the integral, and I need to change the order of the integral of this question, right? So first of all, let us understand that the integral is being denoted by I, okay? We have to find out whether the constant limit is denoted in x or they are mentioning in y, right? So see, when x, the limit is 0 to 1, and here you can see y is present in the integral. So this limit must be of x. Yes, there is no problem. Then obviously these are the limit of y. So our first objective is clear. And what is that? Our y is working in y mean constant, and our x is moving in a variable type function, right? So when we change the order of integration, it looks like what happened basically. Before to moving forward, we have to plan where basically this integral being integrated, right? So when we take y from 0 to 1, obviously this is entire x axis, and the y lies between where to where? You can see y lies between 0 to 1. Okay, so these are the curve, right? So when we are talking about x equals to 1, so this line is x equals to 1, and when we are talking about this y equals to 1, the point of intersection between these are 1 comma 1, right? No problem then. And where is the second value of x? This is exponential y. So student, you can say x equals to e raised to e raised to power y, something like that. This is the graph, something like that. When we interact the line y equals to 1 with e raised to power y, then we will have the e power e1, when comma 1 is the point of intersection. So student, basically this is my covered region and this is my area of integration, right? Now I'm going to change the order, right? So let's change the order of integration. What happened? I must to take some parallel strip. You understand what are the meaning of parallel strips here? So first of all, we must take two strips, right? One must be work parallel to the x-axis and second one must be the parallel to the y-axis, right? It will help us a lot, right? So see here, when I'm talking about the x limit, it is working in case of 1 to e power y, right? Then I must take a parallel strip. Let me cross check whether the integral is obviously perfectly given or not given. So you can see in the original question, the x lies between 1, okay? So the parallel strip is obviously parallel to x-axis and its one end is mentioned on the pole, or you can say on the line x equals to 1. So the lower limit must be from x equals to 1. Now let's took the another end point of this parallel strip. It is basically moving on the curve y equals to e raised to power x equals to exponential y. So I get my limit. Similarly, student, you can now change by 90 degree of angle your strip, and now you have to identify what are the end points of this strip which is being parallel to the y-axis. So the bottom is always there. You can see here. And student, the largest strip you can form, that is there. So it must be 0. So you can see your y equals to 0. Your x-axis, your y is obviously from here to here, your y is 0 and the largest highest point on y is what? 1. So the limit is perfectly done. So one thing is very much clear from here. Whatsoever be the limit of the integral is given to you, you can find by tracing the curve or by taking the mean graphical representation of the curve. Mean you can verify your limit. Now I need to change the order. So let's took here. Now student, my limit must be constant in x, okay? So let's take a parallel strip which is parallel to the x-axis, okay, no problem. So here is all parallel strip being parallel to the x-axis. Can anybody suggest what is the initial point and what is the end points of this parallel strip? Then you can say x is 1. 100%. You can take any number of parallel strip, those are parallel to the x-axis. You can find the end point is always there on x equals to 1, okay? Now let me cross check the second end point, you can say, of all these parallel strips. So you can see the end point is lies on e power 1, which is there, x is e. So by transferring the order of integration, now you understand, basically we have changed x from variable to x from constant, or you can say from x variable to x constant. Now we have to convert the y, we have to find out the variable values of y. So we must evaluate the parallel strip, those are parallel to the y-axis. You can see the end point, or you can say the initial point of this parallel strip which is parallel to the y-axis is definitely focused on this curve. Yes, this curve. And you can say the curve, the equation of the curve was x equals to e raised to power y. Then obviously student, we can have the value of y which is log of x based on e. So what happened here, I have mentioned it y from log x. And what are the above point? You can say the highest point of each and every strip, that is on y equals to 1. So here I have mentioned. So this is the pattern, and you can say this is the method to change the order of integration, and we get this kind of the integral by changes its order of integration. I hope this question is familiar with all of you. Then also having the another example. This example and even this question is very important, right? So let me check the question. We have to evaluate the integral, but before we have to change the order of the integration. That's good. So student, first of all, we have to look what are the limits and where they are mentioned in the original question. No problem. So student, as you can see here, y is mentioned in the limit. So of course, these are the limit of x. Therefore, you can say x is lies between y to a. Obviously, if x is there, then these are the limits of y. Now we have to plot the reason, and the reason is x between x to y, then x to a, and then we have y to y0 to y equals to a. So we can have this type of diagram. Now you can verify your limit. So student, by plotting this reason, you can verify your limit. X is equals to y. This is the line x equals to y. Okay, and then the end point of x, that is a. This is x equals to a line. So student, you can verify your limit x. You must take the parallel strip parallel to the x axis, and from any number of strip you can have the limit. You can verify the limit. Then x is always moving between y to a. That's done. Now we have to look on the y0 to a. Then obviously student, you can see this is the largest and the lowest value of y. Those are working between 0 to a. 100% my limit is verified. Now student, I need to change the order of the integration. So one thing is clear, very much clear. Then we have to change. When we have to change, then of course x was their variable. Then we have to put x first like constant. And then student, y was constant there. Then we have to convert the y into its variable value. Nice. So student, when we are looking to have x constant, then we must have the parallel strip parallel to the x-axis, and anyone can identify that x is lies between 0 to what? A. So student, now your x is lies between 0 to a. Yes, you can see here, right? So both the upper and lower limit of x can be evaluated. Now when we have to convert y into its variable form, then we have to take the parallel strip parallel to the y-axis, and anybody can find out that the lower value of y is of course 0 and is always interacting on this line, and the equation of the line is y equals to x. So the upper limit of y is what? That is x. So now we have already changed the order of integration. It's a simple integral now. We have to just simply integrate. So student, it's directly a formula, and first of all we have to integrate with integral. We have to cover the integral in respect of the variable limit is always. So obviously student, I'm going to integrate this integral with respect to y. First, though it's tan inverse y by x, then I must take y from 0 to x. In this process, we can have the value as tan inverse 1 is obviously pi by 4 and tan inverse 0 student 0. So of course, now as pi by 4 is a constant value, I can have the integral of dx, which is x, and from a to 0 we get the answer. So student, in this question basically we have understand again second time then how to change the order of integration, and then after changing the order of the integration, how to calculate, right? I have another example. Now the order of the question is slightly different, and it's maybe going to tough, right? So I have another combination where I need to change the order of integration. So as per obviously the rule, we have to identify whether the variable, which limit is variable and in what type of variable. So student, as you can see, x squared to x to 2 minus x is mentioned over there. So it is 100% clear that the limit of y are there in on the second integral, and as 0 to 1 is there, these are the limit of x from 0 to 1, right? So now we have to trace where is my curve. So student, as y equals to x squared and y equals to 2 minus x given to us, so this equation can also be written as x plus y equals to 2, and student, it's a parabola. As you can see, the power of x are even, so the parabola must be symmetrical about the y coordinate, right? And this is the equation of the straight line. Very easily you can identify. Now this is the straight line passing through the coordinate axis on 0 2, and student, here you can see 1 comma 0, right? And this is the equation of the parabola. So now we must identify the point of intersection of the straight line and the parabola. This become our reason. We must very careful to identify the common reason, right? So this is my reason. Okay, very good. So now let me cross check whether my reason has been plotted perfectly, or is there any doubt, right? So when I'm talking about the limit of y, then there must be a parallel strip parallel to the y-axis, and anyone can have the equation. Then the bottom line of the y is mentioning on the parabola, which is y equals to x square. Fantastic. Then the upper limit of what y is obviously on this line, and what is the value of y from this straight line? So it is of course 2 minus x. So student, I have plotted the perfect region. Now I need to change the order of integration. So no problem, student. Now I must change the order of integration, and of course when I am going to change the order of integration, one thing happen. The variable limit y must be present in x now, and the constant x limit must be present in the form of y. Okay. So now when I am taking one parallel strip with respect to x, then student, what happened basically? This is of course now changing the region. You can see from here. You can see from here. You can see this is the end point of the strip which is parallel to x-axis. But unfortunately, student, you must understand that what happened basically. This end point of the parallel strip which is parallel to x-axis interacting with pole and the straight line. Then but what happened here? This parallel strip of course on the y-axis from the left hand side, but on right side the region has been changed. Now this is not the straight line, this is the equation of the parabola. So we must, this is the very important question, we must divide the region into two different parts. What exactly done here? This is very important concept. Then where we have to divide the region into more than, you can say, one part. So I have divided the question into its two part. Now you can see, you can take any number of parallel strip now, but the end point is always interacting on the same number of equation. From left it is interacting on the y-axis, and from right it is interacting on the line y equals to x equals to 2 minus y. From there, from this point C, now you can see the equation, the parallel strip interacting on the y-axis, but now from this point it is 100% interacting on the parabola. So reason is clear. So student, one thing is 100% clear in this question. We have to convert, when we have to change the order of the integration, we must convert this integral into two different parts, and we have to add them, right? So if I assign that this is the part 1 and student, this is the part number 2. So let me clear the reason. So student, in the first region we have to choose the region, right? So if the point of intersection are 1, 1, then obviously here student, the point of intersection on the y-axis must be 0, 1. So your y lies between 0 to 1. When this y mean parallel to the y-axis, we are on 0 to 1, then what happened with respect to parallel to the x-axis? We are on 0 only, like here x is 0 on y-axis, student, x is always 0. And here basically we are interacting on the parabola, whose equation was what? Y equals to x square. We can have the value of the y, right? We can take the value of mean x in terms of y, which is under root of y. So one reason is done. Now we have to enter into the second one, right? So what happened from here, student, y lies between 0 to 2. There you are. So y lies between 0 to 2. What happened with respect to x? So we must understand this by taking the parallel strip parallel to the x-axis. We are basically on x equals to 0, mean y-axis. And from here we are interacting on the straight line whose x equals to what? 2 minus y. So it was the very important question for your exam purpose, student. You must understand the concept of this question, and from here we can definitely integrate the integration by using usual method of integration. Next I have, student, another important question. The concept is almost same, but little bit you can say the answer must be different, but I must ignore this question, right? I have another question for you. So this is again, student, you can say there 0 to 1. In different question you will have like 0 to 4. The graphical representation of the question is 100% same. Next, I have a different question, and student, this is another very important question for your exam, right? So there we must understand that we will have a different type of integral, and we will have different type of graphical representation as well. So let me read the question. What is that? we have to evaluate this integral exp mean exponent x to power minus x square by y with the dy dx, and we have to change the order first. Okay, no problem. So student, as you can see, x is mentioned there, right? So it is the limit of y. So the second limit is for y 0 to x, then of course x is lies, student, from 0 to infinity. The limit of integration is also mentioned here, right? So let me plot the reason. Okay, so student, you understand what is the line y equals to x? It's a line passing through with the, you can say, coordinate axis breaking into the 45 angle. So this is a line which is going on with y equals to x. Okay, then I have recovered the y equals to x. Then I need to take y equals to 0, which is my x-axis. That is also going on process, no problem. Moving to the x. Student, x equals to 0 mean I must take y-axis, which is x equals to 0 line. So y-axis, and from here x equals to infinity. So x equals to infinity, that mean this region is going on. So this is in the increasing order. This is your region, right? And you can also cross check your limit whether you have plotted a good region or you have plotted the wrong one. Let me cross check it. So student, when I am taking the value of x, so I must take the parallel strip parallel to the x-axis. Anyone student can identify that the lower limit of your x on the parallel to the x-axis, the largest end point of the strips here, which is 0 origin, and this is the endless process in the right hand side. So student, your top limit mean the end of the strip on the right hand side is somewhere on infinity, right? So x is limit, x limit perfectly match. Now I must check the limit of y. So student, I must take the parallel strip parallel to the y-axis. The bottom is on, you can say, x-axis where y is 0, done. And the upper portion, you can anytime identify by taking not a single strip. You must take most of the parallel strip parallel to the y-axis so that you can verify the region, right? So 100% the lower limit must be 0 in case of y, and the upper limit is always clashing with the line y equals to x. Here you are, right? So I have plotted a good reason. Now I need to change the order of the integration. Then of course student, here you can see y is variable and I need to convert y into its constant value, and you can see x is a constant one. I need to convert it into its variable form. So this integral must be written in the case of, you can say, y I must say first and x I must say second, because in the first, from the left hand side, we always take the constant limit first, right? So when I am dealing with y, student, you can see I must take the parallel strip, those are parallel to the y-axis. There you are. So student, when I moving forward, so you can see what are the value of y. This is, so first I need to take the constant value of y. So I must take the parallel strip parallel to the y-axis. Of course student, here your lower limit, or you can say the lower point of the parallel strip on x-axis, then of course the lower limit of the y must be what? 0, right? Moving forward, you can say when y is going on, this is like y equals to x. So what happened when I am dealing with the y0? So of course this is an endless process. This is a going on process and increase. So student, when this is going on, then y-axis is also going on. So what happened? My limit y is somewhere on infinity. No problem. Now I must calculate. So the y limit is 100% from 0 to infinity. Now I must calculate the variable limit of x, student. So I must take the parallel strip. Those are the parallel to the x-axis. These all are parallel strip, those are parallel to the x-axis. Anyone can identify there are the first end point of each and every parallel strip. So student, where I am classing, basically I am classing on y equals to x. So what you suggest, the value of x is what? It is y. And of course when this line is going on the endless process somewhere on infinity, so the upper limit of the x, you can say x must be infinity. So no problem, we have just changed the order of integration. Now what happened? We simply integrate the integral, which is very easy. First of all, we have to move the integral with respect to variable, which is dx, right? So x exponential minus x square by y can be integrated in some way, and of course from here the integral is integrated in case of dx. Now we have to put up the limit of x from y to infinity so that we can have the answer in case of the y. Now from there we can integrate our integral with respect to y. So finally student, we get the half answer. So now this question is completed. We have covered the change of order of integration, rather than we have also solved the question. So student, this is one more another question. The digits only the different, that there is no difference on the, you can say, reason, but the integral must be different. So we will have the same idea for this question, but the process of integration must be slightly different, because you can see the question is slightly different. So we can integrate. Here you also can see that the x limit is variable, so we must take the integral with respect to x first, and in case of exponential y, then the integral with respect to x must be exponential xy by y. So we can directly solve this question. So now student, around at the end of this lecture, I have another most important, and you can say the last important question from the change of integration. Here student, listen up. You can see when the change of order of integration is given to you and there is no such proper integral mentioned inside the integral, then the agenda is to only change the order of integration. There is no hard and fast calculation behind the integral. So I am going to only change the order of integration, because v is a function which is given to us. I'm failed to integrate, but of course I'm going to change the order of integration. It's a very, very important question, because student, from the, you can say, limit, you can trace that both the one is parabola and another is a circle. So it's slightly different question. Okay. So student, as x is mentioned here, these are the limit of y, of course, and these are the limit of x. So obviously it is mentioned here that x is from 0 to 2a, and then of course y is from under root 2ax. We can squaring both sides, and we will have like y square equals to 2ax, which is a parabola. This is of course parabola, and the power of y are even, and 100% the parabola is symmetrical about the x-axis. From this equation student, we can square, and even we can make it like perfect square of x minus a. It's a circle student whose center is lies at this is x mean a comma 0 and whose radius is a, right? So this is some kind of like this type of, you can say, mean there is a circle whose center is mentioned at somewhere on a. There you are. So this is the center of the circle, and this is the radius of a, which is like your circle. And what is the equation of this parabola? Because this parabola is symmetrical about x-axis, so the only visible part, those is going to mean clash with the circle, and the parabola looks like this, right? Even you can cross check whether you have plotted the good one or you have plotted the wrong one reason, right? So let me cross check it. When I'm taking the parallel strip, those are parallel to y-axis, then the lower point is there, right? And what is that? That is a circle. So the lower limit get matched, right? And what is the upper point? This clashing with the parabola where y is equals to under root 2ax. So 100% my reason is good, because it verified by the reason. Now I'm going to change the order of integration. Okay, no problem. So student, when y as a variable limit is given to me, I must convert the question, you can say, constant in x. So I must have parallel strip, those are parallel to the x-axis. Okay, no problem. Let me cross check. There is a parallel strip. Student, there is also a parallel strip. There is also parallel strip, but what happened after next? You can see if I am going to take a parallel strip, then it clash over here. And if we take one parallel strip, it start from this point and clash over there. So student, as you identify very deeply, you can have that there must be 1, 2, and student, there must be 3 reasons in this question, and we have to add all the 3 reasons. This is one of the finest question to understand what is the basic concept behind to change the order of integration. So now let me clear you how to get the integral, proper integral. So student, let's start with x. This is because these are the limit in y. So these are the limit of x and this is the value of y. Okay. So student, in case of parallel to y-axis limit, in case of parallel to y-axis, this is start from here, and where is the largest height of the curve? This you can see 2a. So student, the y point is lies between 0 to 2a. But here you can first of all verify where is your y. So student, this is your y from a and this is your y square equals to 2ax. So I can have the value of x, which is y square by 2a. You can find out from this equation. Here x equals to y square by 2a and the lower limit is what? Y equals to 2a. So this is student y equals to 2a. So from there to there we can have a value. But you can see this is the point of intersection. This is the point of intersection. So this is a height again. This is a height again, and from there to there again a height. So student, first y lies between 0 to a. There you are. First y lies between 0 to a. Then it's again lie 0 to a in this case also. And then from this point y equals to a, it's moved to the y equals to 2a. So this is the first integral. This is the second integral and this is the third integral, I must say. So now you can verify the integral. We have three parallel strips. One is from there, second is from there and third is from there. So student, it was the last question which I have discussed on the change of order of integration. Now you can understand and you can recall each and every question which is given to you in different textbook. So thank you very much. Jai Hind everyone.